So in this lesson, we're going to learn about how to convert from moles of A to mass of B and mass of A to moles of B. These are our two-step conversions. That means we're going to need two conversion factors. So the conversion factors that you will need are the mole bridge or the mole ratio. And remember from yesterday's lesson that when you use the mole ratio, moles of B is always in the numerator of the mole bridge, and moles of A is always in the denominator. Also remember that the mole bridge comes from the balanced equation. The second conversion factor that you will need is molar mass. Now remember, we learned how to calculate molar mass in the last chapter. And to do that, you'll need your periodic table. Remember that the units for molar mass are the grams divided by 1 mole, or as we said, grams per mole. With the molar mass, you will always notice that moles will have a 1 beside of it. In your mole bridge, the numbers that go beside the mole bridge are going to come from the balanced equation, so there will not necessarily be ones. There will be the coefficients from the balanced equation. Now, you need to understand the symbolism here that I'm using. So anytime I say A, moles of A, or mass of A simply represents the given substance. So the molecule or the atom that you are starting with in your given. And substance B is the substance you're trying to convert to. So it's your unknown. So A represents the substance that is known in the given, in the problem. And B is the substance that you're trying to convert to. Now we're going to do some examples, but before we do, I'd like to kind of show you a template, if you will, for converting, so that if you get stuck on a problem, you can kind of go back and take a look at how to set it up. This is will give you the format that you would want to use to set your problems up. So the first format we're going to look at is if you're asked to go from moles of A to mass of B. So if you're going from moles of one substance, if you're given, and you're trying to convert it to mass or grams of another substance. Now remember, you always start with your given. So the given will always go here in the upper left-hand box of your T-chart. And your given will be moles of A. Now in this particular chapter, it's extremely important that you keep up with not only the unit, which in this case is moles, but also the substance. So I'm trying to color coordinate these so you see there's a distinction. So you have a given number, a given quantity, the given unit is moles, and then the substance is A. So what we need now is we need for moles of A to cancel out. Now remember, the way dimensional analysis works is everything cancels diagonally. So if you need moles of A to divide out, then you're going to need the unit moles and the substance A on bottom here. So you're going to put moles of A on bottom, and this will be your mole bridge in your two-step conversion. The mole bridge always goes nearest where you see moles. So if moles is your given, your mole bridge will go first. The mole bridge will have moles of A on bottom and moles of B on top. Remember, the bridge lets you cross over. You're trying to cross from A to B. The mole bridge numbers, notice I put little hashtags here. These numbers come straight from the balanced equation. You don't have to calculate them, you just pull them in, and they are counting numbers. So these are from the balanced equation, and they are counting numbers. You might want to write that down so that you will remember that. So from the balanced equation, and not only are they from the balanced equation, they are counting numbers. Now what that means is they have unlimited sig figs. Now, the second conversion factor will be your molar mass. And so since you're trying to convert to mass of B, that means the last unit you're going to see in the upper right-hand corner of your problem is grams of B. And this is where your molar mass that you calculate will go. And so in molar mass, remember that it's always grams per 1 mole of the same substance, so 1 mole of B. Now let's look at our units and let's see how they cancel out. Moles of A will divide out with moles of A. Moles of B will divide out with moles of B, and you'll be left with grams of B. So that means that once you plug into your calculator, the unit left will be grams, and the substance will be B, the substance you were trying to convert to. So let's look at some problems, or a problem that will be a two-step problem. Now I have already balanced this equation for you. So since what we're working on right now specifically is the conversion itself, and balancing equations is something that we learned about in several chapters ago. So I have already balanced these equations just for time's sake. On the homework or on the quiz or on the test, you will have to balance your own equations. Just keep that in mind. You don't want to forget. You want to keep brushed up on that as well. So number 1 says, what mass of oxygen, so I'm going to underline this, you might want to highlight if on your paper, what mass of oxygen combines with 2.0 moles of magnesium in the above reaction? Now remember, you're only going to be dealing with 2 substances at a time. So one thing that I think is really important, and just a strategy that I think will help you, is when you read your problem, not only underline the key information, your known and your unknown, but come up to your chemical equation and let's circle the molecules or substances that are mentioned. So it says what mass of oxygen, so it is asking specifically about oxygen. There's your O2, and then it asks you 2 moles of magnesium. So here's your magnesium here. So notice it never mentions magnesium oxide. That means you're not going to need that molecule or that coefficient. So we're just dealing with our 2 substances here, magnesium and oxygen. Now, let's start with our given. Always start with your given, which is the number in the problem. So we're going to put 2.0, and then we're going to put moles, because that's the unit, and the substance that we're starting with is magnesium. So this is A, substance A is magnesium, 2.0 moles of magnesium. Now put your T-chart, and nothing will go underneath your given, just like before. Now, again, what I would do, because we're going to also learn about a 3-step problem in our next lesson. So what you want to do is have a strategy, a way that you approach every problem. And so what I always do after I kind of identify my known and my unknown, I write down my given, 2.0 moles of magnesium. I put my T-chart, and I'm going to come over here all the way on the far right, and I'm going to go ahead and write down the unit that I'm looking for, which is mass. We know that mass is grams, and it's of oxygen. So the formula for oxygen is O2. And that is important for you to always make sure you match your formula with the formula in the chemical equation. So moles of A to grams of B, it's going to be a 2-step problem. Now our template that we just looked at, what I showed you is that you need moles of magnesium to cancel, or moles of A to cancel. That means moles of magnesium will go on bottom here. This is our mole bridge, and in the mole bridge, moles of A goes on bottom. In this case, A is magnesium, and moles of B goes on top, and B is the substance you're trying to convert to. So in this case, B is oxygen. So we're going to put moles of oxygen, O2, right here. This is our mole bridge, and that comes straight from the balanced equation. So let's go ahead and pull those numbers in. From the balanced equation, the oxygen has a 1 beside of it, so you'll pull your 1 in, and that comes from the balanced equation there. And the magnesium has a 2 beside of it, so we're going to put a 2, and that comes straight from that part of the equation. This is going to let moles of magnesium divide out. So now what we need is we need moles of oxygen to divide out. So you need to put your unit, moles of O2, down bottom. Now notice I'm not bringing any numbers with it. I'm just putting the unit and the substance. We need grams of oxygen on top. Now remember from our template, this is the molar mass. And for molar mass unit is always the grams per 1 mole. And that will always be grams per 1 mole for molar mass. So we got to calculate molar mass. Let's do that real quickly. So it's O2. So it's 2 times 16.00. Remember, we learned this in the last chapter, chapter 10. That's going to be 32.00 grams per mole for the molar mass of oxygen. So let's plug that in, 32.00. Notice I keep 2 decimal places in my molar mass because we always run our molar masses to 2 decimal places. This is going to let moles of oxygen cancel, and you're left with grams of oxygen, which is what you wanted. So now we're ready to plug this into our calculator. So you're going to have 2 times 32, which is 64, and then 64 divided by 2 is going to give me 32. So our answer now needs to be rounded to proper sig figs. So we have 2 sig figs in our given, and we have 4 sig figs in our molar mass. And again, the mole bridge is counting numbers, so they have unlimited sig figs. So 2 sig figs is what we need to round this to, so we're going to round it just to 32 grams of oxygen. All right, let's look at the other template. So in the last problem, we went from moles to grams. So what if they need you to go from mass or grams of A to moles of B? So mass to moles. Let's look at that template. If you were asked to go from mass to moles, you would start with the given. Again, you always start with your given. And it would be grams of A. Again, substance A is the given molecule, the substance you start with. So we need grams of A to cancel. So that means grams of A has to go on bottom so that it will cancel out. You want it to cancel. That means this is the molar mass of A, because molar mass is the only conversion factor that we've learned about that has grams in it. Since this is a molar mass, it's grams per 1 mole of A. So this will be a 1. Molar mass is always grams per 1 mole of the same molecule, same substance. All right, so then you would need moles of A to cancel. That means moles of A, the unit has to go here diagonal. Substance has to match. It has to be A. It has to exactly match so that it exactly cancels out. Moles of B is what you're looking for, so that will go on top. Now recall what I said before. When you're using the mole bridge, and that's what's going to be here, moles of B is always on the top in the numerator. Moles of A is always on the bottom in the denominator of the mole bridge. The numbers for the mole bridge come straight from the balanced equation. This is going to let grams of A cancel with grams of A. Moles of A cancel with moles of A. You would be left with moles of B, and that's what you're looking for. So let's look at an example of a problem like that. So here again, I'm giving you the balanced equation. I've already balanced it, 5, 2, 1, 4. And the problem says carbon disulfide is produced through the following reaction between coke, carbon, and sulfur dioxide. If 8.0 grams of sulfur dioxide reacts, how many moles of CS2 are formed? So I've underlined the key pieces of information, my known and my unknown, and now I'm going to come up to the chemical equation and circle them so that I don't want to get confused with any of the other molecules, because there are 4 substances mentioned up in the equation, but only 2 substances in the problem, and they're the 2 you want to focus on. So it says 8.0 grams of SO2. So we're going to be dealing with the SO2, and moles of CS2, we're dealing with the CS2. That means we're not using the carbon monoxide or the carbon. We're only going to be dealing with these two molecules in this problem. So again, let's start with our given. The given is the number 8.0 grams of SO2. So that's what we're going to start with, 8.0 grams of sulfur dioxide. And I'm trying to convert moles of CS2. So I'm going to come over here, moles of CS2. Again, grams to moles is 2 steps. So I'm going to set it up for 2 conversion factors. We need grams to cancel. So I need grams. Now again, you got to keep track of grams of what? This is SO2. And that means this is our molar mass, because molar mass is the only conversion factor that has grams in it. And so that means up here we're going to see a 1 mole of SO2. Again, that's just a pattern you're going to always see with molar mass. It's always grams per 1 mole. So we need to calculate the molar mass of SO2. So go to your periodic table and let's figure out. You have sulfur is 1 times 32.07. Again, always go to 2 decimal places with your molar masses. And there's 2 oxygens, so 2 times 32.00. I'm sorry, I'm doing that a little bit too fast. Let me get my eraser out. 2 times 16.00 gives you 32.00. So now we're going to add these. So that's going to give us 64.07 grams per mole. All right, so this is going to plug in for my molar mass, 64.07 grams per mole. This lets grams of SO2 divide out. So now we need moles of SO2 to divide out. So that means the unit, mole, needs to come down here, and SO2 is the molecule that goes with it. And we're looking for moles of CS2, so that means on top, moles of CS2 goes on top. This is our mole ratio, or the mole bridge, and remember the numbers for the mole bridge always come from the balanced equation. So for the CS2, we're going to look right here to get his coefficient. That's a 1. And for the SO2, we got a 2. Again, those come from the balanced equation. These are counting numbers. So we're going to plug this in our calculator. We have 8, and that's the only number on the top. So you're going to say divided by 64.07 divided by 2. So again, 8 divided by 64.07 divided by 2. Now we need 2 significant figures in this answer, so when you plug that in, you should get for your answer 0.062. Double check that real quickly just to make sure. All right. Yep, I get the same answer. So let's look at one final example. All right. Our last example here is similar. It's a 2-step problem. It says how many moles of mercury 2 oxide are needed to produce 125 grams of oxygen. So again, I've underlined my known and my unknown. So 125 grams of oxygen is mentioned. That means I'm using this molecule, and that's understood 1. And it says mercury 2 oxide. So this is the molecule we're looking at here, the HGO. They're not talking about the mercury, just mercury 2 oxide. So let's start with our given. We have 125 grams, and that's of oxygen. So remember, look up at the balanced equation to get the right formula. So O2 is the formula for diatomic oxygen. Remember, when oxygen is by itself in a chemical equation, it's always diatomic. And we're trying to go to moles of mercury 2 oxide, so moles of HGO. All right, let's get our units to cancel. We need grams on bottom, so grams of oxygen are going to go on bottom, and this is molar mass. So 1 mole of oxygen goes on top. The molar mass of oxygen is 32.00. So again, we know that because it's 2 times 16.00 from the periodic table, and that's how we get that 32. This lets grams of oxygen divide out. Now we need moles of oxygen to cancel. So moles of O2 goes on bottom, moles of HGO goes on top. This is our mole ratio, and it does come from our balanced equation. So we're going to have a 2 moles of HGO and a 1 for the moles of oxygen. Again, those are counting numbers. Moles of oxygen cancel, so the unit you want is moles of HGO, and so that's how you know you set it up right, because all your units are matching. So now we're going to plug this in. So 125 times 2, and then we're going to divide that by 32. So 125 times 2, and then divide by 32. Make sure you're plugging this in your calculator so that you are following along, and you know and you feel confident that you're plugging it in properly. We need 3 significant figures on this one, so it's going to be 7.81 moles. All right, so that's our lesson for today. Next time we will learn about our 3-step conversions.